Hey everybody, here we are today. Today we're going to start talking about a new aspect of chemistry, which is one of the most important molecules that we are going to talk about this year, and that is water. So we're going to spend today's lesson talking about water, tomorrow's lesson talking about water, and then we got a couple little activities that'll help us to really kind of cover and go over all the details associated with water. So without further ado, let me move on down to the corner and we'll get started with today's lesson. Of course, I probably should have had this PowerPoint operational and ready to go, but we're going to start out with something new for us with this video. I'm going to actually watch a video within a video. So it's kind of like a video inception. So please just bear with me for the next couple minutes here while we watch this video about how polarity makes water behave strangely. And it's actually going to go over a lot of the properties of water that we are going to then talk about this year or this class. So I'll disappear for a second.
How come some insects are able to walk on the surface of a pond, but you quickly sink to the bottom when you try to walk on water? And why do lakes freeze from the top down in winter? In a word, the answer to all of these questions is polarity. Water is a simple molecule made up of one oxygen atom and two hydrogen atoms, but it is essential to life. In fact, water makes up approximately 60% of the adult human being's body weight. The polarity within those water molecules gives this common substance the properties that make it unique and life-sustaining. Polarity refers to the unequal sharing of electrons within a molecule. For water, the bonding between the oxygen atom and two hydrogen atoms within a single water molecule is like a tug of war between a big, strong football player and a cute little toddler. Oxygen is a larger atom with more protons in its nucleus than hydrogen. These positive charges are like a person's physical strength. They are able to attract the negatively charged electrons in the bond, just like a strong individual is able to overpower a weaker individual in a tug of war. So, oxygen is able to attract more than its fair share of electrons. Because hydrogen is smaller and has less strength, or fewer protons, it loses the tug of war and attracts fewer than its fair share of electrons. So the oxygen in water behaves as though it's negative, and the hydrogens behave as though they're positive. The bonds within a single water molecule are called polar covalent bonds. Covalent means that the electrons are shared. But, as we just learned, polar means that these electrons are not shared equally. In water, the oxygen acts negative, and the hydrogens act positive. Since negative and positive attract, that oxygen is attracted to the hydrogen atoms in neighboring water molecules. A special type of bond forms between water molecules known as a hydrogen bond. Hydrogen bonds don't just happen in water either. They can form between a water molecule and different substances that are polar or ionic. Water's ability to stick to itself is called cohesion, while water's ability to stick to other substances is called adhesion. Now, think back to the initial questions. First, why are some insects able to walk on water? Surface tension due to hydrogen bonding creates a thin film on the surface of water that gives enough resistance for super light insects to walk on. You can't walk on it because the hydrogen bonds aren't strong enough to hold you up. Why does ice float on top of liquid water? For most other substances, the solid state is more dense than the liquid state, but that is not the case for water. Hydrogen bonds keep water molecules farther apart in frozen water than in liquid water. The farther apart the molecules are, the less dense that solid is. So ice is about 9% less dense than water, which means it floats on the top. That's why lakes freeze from the top down and aquatic life is able to survive through a cold winter every year. It is the polarity of the water molecule and the resulting hydrogen bonding that account for water's unique properties. So, the reason that water is so special, from inside your cells to the world's oceans, is simply because it is a polar molecule.
And I'm back. All right. So hopefully we understood just a little introduction about How come water behaves the way it does? It actually has to do with its chemical arrangement. If you remember from previous lessons, we talked about the structure of an atom, the idea that electrons and they're sharing different things, and that is what's creating this polar molecule and specifically hydrogen bonds. So remember, we talked about that with the different types of bonds. A hydrogen bond is not a bond between atoms, but rather a bond between molecules. So that's really important for us to understand. All righty, moving on. Oh, sorry, click. Moving on. Here we go. Water. What is water and why is it so important? Well, water makes up about 71% of the earth. Okay, it also makes up about 71% of your body. It varies depending on your level of homeostasis and where you commonly operate at. For the most part, people, though, are about 70% water, which is incredible because it means, most of your weight is water. So if you ever go for like a long run or something like that, or a lot of these like wrestlers or different other sports where you have to cut weight, oftentimes they'll cut water weight. So you lose a lot of water, you dehydrate your body. It doesn't necessarily mean that you've lost all that weight. What it actually means is you've lost all that water, and you're probably going to replenish that water, after you've done your weigh-in or after you've done your things. And anyone who's ever had to cut a lot of weight, if you just stop drinking a lot of water and exercise a little bit, you'll know you feel very, very sluggish, very, very tired. And that's because you have a very low water amount in your body. Water is incredibly necessary to carry out a lot of our biological reactions. It's what we use to transfer molecules. It also will dissolve a lot of molecules. And we're going to kind of talk about why water is so important to life over the next couple slides. So first off, let's go and talk about the chemistry of water. You should probably know this by now, but I just want to kind of quickly review it. Water has a chemical formula of H2O. That 2 actually should be a little subscript. That's me being a horrible teacher. Please don't request that I get fired over that. It means that there's 2 hydrogen atoms to 1 oxygen atom. It is a polar molecule, which means it has a positively charged end and a negatively charged end. So that's incredibly important. And it also will commonly form hydrogen bonds. And remember, those hydrogen bonds are between molecules, but not between atoms. So what's happening is the water molecules, the positive end of water molecules, sticking to the negative end of a water molecule, and that's kind of holding them together. So water kind of wants to hold itself together, bond to itself. Now, why do we spend so much time? Why are we caring about water? Why are we doing all this? Again, it makes up most of your body weight. Okay, most of your body, somewhere between 60 and 95% of most organisms are made of water. So if you talk about a lot of things, like I know I do a lot of work with productivity of ecosystems and with my other students, and we take a bunch of the plants we collect, we dry them, and then you see how much water weight was lost from those plants. Or think about firewood, or any of you that ever cut down trees, stuff like that. Fresh logs are very, very heavy, but if they sit for a month or even a month or a year is best, they really dry out. They lose a lot of water, and therefore they lose a lot of their weight. Water is incredibly important to the biology of organisms as well. It's going to help different molecules or ions move around. It's going to help them to collide. It's going to help them to interact. Therefore, you'll get different chemical reactions to take place. It's also going to help to lower the concentration of different things inside your body. So for blood, it will make your blood easier to move around. It'll help to maintain the pH levels within your blood. It allows chemical reactions to take place. A lot of these compounds are pretty much inert, but when they're dissolved in water, then all of a sudden they become more reactive. They become ionized, and it helps you to maintain your body temperature through sweating and stuff like that, through homeostasis. So it's incredibly important for maintaining your body temperature. Now, certain organisms don't sweat, like dogs, for example, don't sweat. But by panting, they're actually moving a lot of water out through their mouth. A lot of water vapor is coming out, and that water vapor is carrying a lot of energy or heat with it. So it's helping to cool down that dog. So let's talk about why water is so unique. That's one of the things that we are lucky. That's why our planet is so lucky, is that we have a lot of water on our planet. We don't know where else there is water in our solar system, let alone the universe. We have ideas that there might be water in different places, but we really haven't found any water outside of the Earth itself. But water is essential to life. And we're going to go and take some time over the next couple slides to go over some of the most famous properties of water. So this lesson's been a little bit longer. We're almost at 10 minutes now. I've got a couple more minutes. I'm going to go through 3 properties of water with you. And then next lesson, we'll finish up with the last couple. So it'll be a little bit shorter in the next lesson. Cohesion. Cohesion is the first property of water we want to talk about. The co in cohesion, think of that as cooperates. This is when water molecules stick together with other water molecules. So it's water to water bonding. And that's really important to understand. Water will stick to other water molecules through the process of hydrogen bonding. And what will happen is that creates something called surface tension. So that's what allows water striders or some insects to be able to stand on top of water. It's what also allows drops of water to accumulate on top of a penny. How many of you have done the water drops on a penny experiment? Well, you can see here that picture on the slide is water sitting on top of a penny, and it's not just falling off. You would think that it would fall off on the sides, but it's really not. It's actually staying put on top of that penny. Next property of water is adhesion. Now, cohesion is when water sticks to water. Adhesion is when water sticks to non-water molecules. So it's something besides water. So sometimes it's like a plant. Like you see here, the dewdrops or the raindrops collecting on a plant. The cohesion is holding the water together on itself, but adhesion is holding it to the plant. Or think about when you drink a bottle of water, there's always a couple drops of water still in there. Why are they still in there? Well, they're actually bonding to that plastic bottle and they're staying on the inside. Or think of your car window, raindrops on your car window, they stick to the window, right? That's adhesion. So water will stick to non-water molecules, but water will also stick to water molecules. When it sticks to water molecules, it's cohesion. When it sticks to non-water molecules, it's adhesion. So here's a little look at a little comic of how you can kind of put the two together. Cohesion, they cooperate, they work together. Adhesion, they work with other different substances. And then that brings us to this last property we want to talk about, capillarity. Capillarity is really, really cool. Capillarity is a process or a property of water that with cohesion and adhesion working together, it allows water to defy gravity. So what that actually means is that I can take a set of water, put it on the table, and have it go up against the direction of gravity. Think about if you put a paper towel into water, it'll actually pull the water up. And that's important. What's actually happening, that pulling of the water up is adhesion kind of bonding water back and forth, bonding onto new molecules. And then the cohesion's pulling all the other water up. This is incredibly important for trees. Think about when it rains, where does the rain hit the tree? Well, it hits the leaves, but the leaves don't absorb the water. The rain actually goes down to the ground and it goes into the roots. Now, even the tallest trees, over a couple 100 feet tall, still will pull that water from the roots, and then they pipe it up through specialized cells that's part of their vascular system. So we have a cardiovascular system in our body where we pump blood throughout it, but trees have a vascular system to move water and nutrients from the roots, which they're pulling it in, all the way up to their leaves where they actually need it for photosynthesis to take place. So what's actually happening here is we're talking about how does that happen? Now, if trees had to expend energy to pull that water all the way up, that wouldn't work at all. They would never be as big as they are. They would never be able to reproduce. But what happens is, again, the adhesion allows the water molecules to bounce back and forth as it goes up, and cohesion's like a big old choo-choo train. They're all holding on to each other as they pull themselves all the way up. I know it's a little confusing. I know I gave you a lot of information in this short little time period. Please bear with me. I'll make sure we go over it another couple times so that you really, truly understand the major properties of water and why it's so important to life. Thanks for tuning in today. Tomorrow, we're going to finish the last properties of water, and I look forward to seeing you guys. So look forward to seeing you on Fridays, and who knows, maybe in a week or so, I'll see you in school. All right, have a great day, everyone.